All right, let's go ahead and get started here with our next topic, which is data storage and sharing best practices. So I'm going to be presenting this material today. A lot of this original content is created by Lisa Gerhardt, who's actually now our Deputy Director for Operations. Lisa is very involved and knowledgeable about data storage and file systems. And so in general, if we, all of us here can answer a lot, probably most of your questions. But if you have any really, really, really tough questions, we'll go ask Lisa. Um, okay, another thing to note is in this presentation, there are a lot of slides that have a lot of text on them. And in general, I want to describe all the information, but I don't want to just read the text on the slides. The slides are meant to be a good resource for you later, but don't feel like you need to be reading every single word on the slides. You can use them later on when if you're referencing this material later on, because there's a bit of text. So. Okay, let's jump in. So, whether you're new to HPC or new to NERSC, file systems are going to be different at different facilities. So this is something that is probably relevant to anyone, regardless of your experience level, is to know what are the different file systems, which ones are you going to be using for long-term storage, short-term storage, so forth. So, as you may have seen earlier today, hopefully, Perlmutter is really one part of this whole system. So Perlmutter itself is what we call the actual sort of compute nodes. That's where all the processing is happening. But then there's all of these different storage options around Perlmutter. So one of them is called Scratch. This is a really, really fast storage that's sort of like hardwired directly into Perlmutter. So we call it local because it's connected directly to the system versus some of the other ones which are sort of connected over the internet essentially. They're close, but they're not directly sort of wired in. And so they are still really, really fast. But not quite as fast as Scratch. And so the other ones here are our HPSS tape archive, the common file system, and home, and there's a couple other little ones as well that we're going to talk about. So mostly in this presentation, we're going to be talking about those four systems shown here in these boxes. Okay, so kind of a nice way to look at some of these is performance versus capacity. In general, if you want something to be really, really fast, sometimes it's harder to have a ton of it versus things that can be a little bit slower. You might be able to have a little bit more of that. So memory is really the space on the compute nodes right next to the processor. Of course, that's going to be the most performant because it's the closest to where the computation is happening. But the second best option is Scratch. So this is a huge flash system that has a really, really high bandwidth data rate, 6 TB, 5 or 6 TB per second. And so when you are doing any kind of active computation where you're reading a bunch of data or writing a bunch of data, you want to be using Scratch because it's going to be the fastest, it's going to be the most optimized for active computation. And we're going to talk more about that in a second, so I won't spoil it. Then there's the community file system. So this is where all of your projects get space to store things. It's not SSD, it's not quite as fast, but it's really, really big. And so you can see the data rate goes from on Scratch, it's 6 TB per second. Now it's like 150 GB per second, a little bit slower. You and I may never notice this, but if you're depending on the computation you're doing, it can be a little bit slower, but still really, really fast. So one thing in this talk is sometimes we talk about like, while we recommend using Scratch for all of your jobs and computations, there might be times when using the community file system is just as efficient and sufficient for your needs, and you may not even notice a difference. Then there is the tape archive. So this is for long-term storage, and you can see here it's huge, right? 315 petabytes, right? So it's like, maybe 10 times, a little bit less than 10 times the size of Scratch, right? So it's a huge amount of space, and this is for very long-term storage. It's called an archive for that reason. And then we have a little bit of other kind of space. This is our global space, and there's sort of two different versions. There's global common. We're going to talk about what that is. It's going to be a place where you can actually keep your software. This is like once you've compiled your software, once you've set up your environment the way you want it, your software stack, you can put it in there, and it's very fast on the compute nodes because it's read only. And then there's your home environment, which is kind of like a little foyer when you enter into Perlmutter. It's really just meant to like store a couple quick things. It's not really for active compute, and it's a very small amount of space. So those are also two that you will come across probably pretty often, but are not necessarily for active compute the same way that maybe like Scratch is. Okay, so a couple things to just know about the policy. This is, just sort of like the ground rules essentially. So we provide our users with a means to store, manage, and share their, data, essentially any data that's associated with your research, and that the data resources are intended for active allocations. So if your allocation, so your project ends, you no longer have an allocation at NERSC, you will need to move your data. We're not going to keep it for you once your allocation has ended. And we have a lot of resources to do that, to transfer data, to take it with you. There's a lot of sort of data movement or deletion modification things that the PIs can handle. So if you're a PI, you will be ultimately in charge of a lot of those things, and you can request help with those things from NERSC. There are Unix file permissions that protect your files. On the sort of default is that the user and the group have some amount of access. So it might be, the user usually has full access, group might have read access. But you are actually able to make changes to those Unix file permissions. So if you need to, and we can help you with that, but we actually have a lot of resources, again, in our documentation that will help you change those permissions in case you need to share with a collaborator or, in your account, in your same project or something like that. And in general, it is your responsibility to change those permissions as needed. So the actual permissions that everything starts with, like the defaults, we are probably mentioned in the documentation. You can also check them on the system yourself, and then you're able to change some of those, most of those. In general, the reason you're here to learn all of this is because you have the ultimate responsibility for managing your data. So we're here to tell you all of our policies, all of the technical things that you need to know about how data storage at NERSC works. But then if something, gets deleted or changed or whatever, it's your responsibility that you've understood why those things are happening or what to do about them. Okay. So if you're ever confused or having issues, of course, you can always reach out. But again, our documentation covers all of this in detail. Okay, so let's do a quick at a glance view at the file systems. As I mentioned, we have this thing called Global Home. The reason I start with this one is because it's the one you kind of land in when you first log into the system. So if you log in and you do CD, it'll show you, or not CD, sorry, you do LS, it'll show you that you're in your home directory. It's a really small little space, and it's not meant for doing active computation. It's really perfect for just storing some source code, some shell scripts, things like that. And it is backed up because it's not a huge space. Everybody gets 40 gigabytes, 40 gigabytes, and you cannot go over that. So you can ask for more space in your home directory, and you shouldn't be using more space in your home directory. Um, It is backed up though because it's pretty small. We can kind of do these snapshot backups. Snapshot backups are 7 days, and I'll talk about that in detail as well. Um, the next system that you might interact with, sort of the next step up, is the Global File System, CFS. Sorry, Global Community File System. This is permanent. So you'll see at home and CFS say permanent. That'll be relative to temporary, which we're talking about in a moment. So files in here are not purged or deleted at any frequency. This is a larger space. CFS is a larger space. It is mediumly performant. So there might be times when you are going to be running jobs from here because it's a larger space and you may have more space. Um, this is shared among your research group or, sorry, your project. So if people in your research group are on the same project, then it's a shared space. And actually, the PI determines how much space you have available to you in this shared space. And actually, the award allocation is what decides how much space I think everyone gets in CFS. Um, so there is a little bit more flexibility, like, hey, I need a little bit more space. You can talk to your PI and get some of those adjustments made if you need to store more data in CFS. Then we have the scratch space. If you remember, this was the one that I said is really fast because it's local to the system. It's large, but it's temporary. So you'll see here we have something called a purge policy. Every 8-ish weeks, files that are not actively being used may be purged. Um, there's I don't know exactly, but there is some way that it sort of checks like what is being used, what isn't. You can't just like touch every file every 8 weeks and it won't get purged. That's not sufficient. There's some amount of like, it's been used, it's been changed, something has happened that it's being used actively. Um, it is optimized for read write on the system, which is why it's not meant for long-term storage, which is why we do this purging because I think you saw it was like 30 something, 36, 37 petabytes. Everybody starts with 20 terabytes on the system, and if you remember, we have like 11,000 users. So, I mean, I haven't done the math recently, but I'm pretty sure this scratch space is oversubscribed. So what that means is that there's some people who aren't using any of their scratch space. There's some people who are using all 20 terabytes. There's some people who might be using more because sometimes you can suggest more, or sorry, request more. What that means is that we have to make sure that we're very efficient with that space, which means if you're if you've left something in there and you're not going to be using it, we will purge it out of theirs to make space for other people who are using it actively. So it's meant for staging data and performing computations and then moving that into a permanent space, for example, CFS. Or if you're done with it entirely, maybe the tape archive, which we'll talk about. Um, yeah, so I'll mention this. There are some slides later on where I talk, where well, not I talk. There's detail, like a lot more details about how you actually use HPSS, which I'm going to probably end up skipping because, again, it's basically stuff straight out of the documentation. So when you're ready to use that, the best place will be to go into that documentation, and then you can really see like line by line what commands to use and so forth. But the point of HPSS, which is the high performance storage system, is it is archival storage. So you've finished a big project, some machine learning project, you have all this training data and validation data and test data and so forth, and you need to keep all of it for a couple years as part of, your whatever research publication requirements and so forth. But it's probably not going to be accessed, maybe, not by your group and probably not by anyone else. So it is meant for archival. And usually you want to make sure you do a big sort of, zip or tar ball of your data and not storing like um, uh, a bunch of tiny little files. And then literally it's a tape archive. So I think I do have a video of the tape robots, which is like the best part. But there's little robots that go around. I don't know how many there's sometimes young like students who don't really know what a tape is or what like a cassette tape is. But if you do know, it's the same as like the magnetic cassette tapes that sometimes people would listen to music on. Okay, so okay, we've talked about a lot of these things. Um, yeah, so this is meant to be a little bit more of a deep dive. I don't want to belabor too much, but I want to put this information up here. Scratch is our performance space. It has the highest data rate. So it's, more than 5 TB per second is the data rate. Please use this for for active computation. And please remember this purge policy. You need to be backing up your data once you are done with your active compute using Scratch. The quota, which means like how much you're allowed to use, is 20 TB. That's a soft quota, means like if you go over it during a computation, that's okay. But at 30 TB, that's a hard quota. So like you cannot go past that hard quota unless you have requested to have more space than that, which is possible because there are times when someone's going to be running a very large computation. They know they're going to be creating 40 TB of data, but then they're gonna, first they're gonna create 40 TB of data, and then they're gonna run some filtering or processing that will fit it down to 4 TB or whatever, right? But they need to first be able to make that 40 TB or however much. So that there is a method for you to reach out to us and say, hey, I'm gonna need 45 TB just to be safe, and then then the processing will take place. It'll take me 2 weeks to process the data, and then I'll be done and I'll move it, right? Um, so the way to do this is to move all your run scripts into Scratch, have your application set up to read and write from Scratch. Some advanced users may want to know about file striping, data striping. There's some information in this box here and more information in our documentation about that, which I'm not going to talk about, but if you need this information, you can find it not only on this slide, but in our documentation. Um, Global Common Software. So this is similar to the Global Home, but Global Common Software is meant for software stacks. Why is that? It's because the load performance is improved and the caching is improved on this file. So it's set up for that kind of thing. So this plot, which is a little bit hard to read and it's also a little bit old. It says shifter here, but oh yeah, we are using shifter. I thought it said singularity for a second. So what this is showing is the read time of some benchmark software or whatever on different dates. And in general, it's like you want it to be really fast, right? So you want it to quickly read in whatever software it needs and then like run the computation. And so you can see the fastest is a like a container. Usually using the container is really, really fast. But then the second fastest, if you're not using container, is, excuse me, what's called common, which is this global common software. And then let's see here. It's actually interesting because a lot of the times it's showing that project is faster, but that might be just for like reading the software, which is why we recommend reading and writing data to Scratch, but reading and writing your software from global common software. Okay, so these are group writable directories that are similar to the community space, but they have a really small quota because they're really just meant for like a Conda environment or some executable or something like that. And so, as mentioned, it's read only on the compute nodes, which so you can write on the login nodes and then read only on the compute nodes, and that makes it much faster and more optimized for running performantly. So that is the way that global common software is used. Okay. A little bit more information about the community file system. This is where you're going to move your data once you're done with creating it or synthesizing it or whatever on Scratch. So it's so funny because we kind of say it's not for intensive IO, but there may be times when you have a huge amount of data that you need to write or a process of some kind, and there may be times when you will want to use community file systems. So I think it really depends on the size of your data. If you have a huge amount of data, you may end up using CFS because Scratch, maybe we can't give you enough space on Scratch. I can't imagine you can give you several terabytes, tens of terabytes, but if there's something even bigger than that, you may end up using the community file system. It's still going to be pretty fast. Um, and again, because this is shared among your project, it's also really set up by having group read permissions by default. So if you need to change that, you can, but the default is that it's meant for, maybe you're collaborating with another graduate student or a postdoc or someone. One person can be creating the data and the other person can read it in and do whatever they need to do with it. Okay. Lots more information on our documentation and some tidbits on how do you access these things. Um, let's see. I'm going to talk about DBS in a moment, so let's skip that for a second. Data is never purged. The only time it would be is if your allocation ends and we are removing it, but it's not going to be purged while the allocation is active. Okay, I'm not going to talk about that right now. Let's see here. Okay, I also mentioned snapshots. So snapshots are basically every day we take a snapshot of a couple of the systems, the home and the community file system, and these are available to you for 7 days prior. So if something goes wrong and it's sort of like version control. So if something goes wrong, you've deleted something by accident, you actually have up to 7 days of the sort of previous state. I don't know how often these are taken, so it's not like you have it must be like once a day. And I don't really know when that happens exactly. Maybe there's more information in the documentation, but there's some amount of version control in that you can go back. But even then, it's not like you can go back to any split second before. It's sort of infrequent. Okay. Um, okay, let's see if I don't know if this is gonna work. Let's see if this will work. This is a video of the tape robot. So these are all the different tapes over here, and then these are the probably essentially the cassette players over here. So this robot gets an address from the user and saying, "Hey, I need you to access this data." It knows which cassette to go and grab because these all have, addresses of some kind, and then it can put it into one of these readers and it can basically, it's a cassette player basically. And so the cool thing is there's this robot who like physically moves around to grab these cassettes. And this is in like a special like chamber. These aren't just like open to the elements because magnetic tape is highly flammable. And so in order not only to protect the tape from, degradation over time, there's also like a lot of like it's like a system that will flood with a certain like inert gas probably if there was any indication that there's like a fire in the building, it'll like, try to prevent these from getting destroyed in a fire, that kind of thing. So they're in these cool little chambers, and then you can sometimes watch the robots move around, which is really fun. Um, so I think, yeah, there's going to be a ton of information here. I don't want to read this, as I mentioned. If you're in a position where you're going to be using HPSS for any kind of archiving, please go and look at the documentation on it and use that documentation for aggregating your data. So, you don't want to send 1,000 tiny datas. You want to aggregate it all up, and then you want to use the sort of commands that have been set up to help you efficiently and correctly save everything as needed. Okay. I'm not an expert in this, so I'm not gonna speak to it too much. But the documentations are an expert. Okay, The home directory is, like I mentioned, is like where you land when you first arrive on Perlmutter. It's a really tiny space. It's 40 gigabytes. That's your quota, and you can't get more. So it's really meant for like teeny tiny things, little scripts, little notes, maybe some Slurm out files. Those are just text files. It is not intended for intense I/O. And it is actually interestingly backed up monthly by HPSS. That's funny that's in here. I didn't actually even remember that. Um, and there also are snapshots as well. So if you do have some like, you're keeping notes for yourself or something like that, you can find those in your home directory. Again, text files, little things like that. Nothing, no big data files or anything. Again, 40 gigabytes, that's all you have. Um, okay, let's see here. Um, Okay. So there's a lot of advice in here. Some of it I've talked about, we want you to use Scratch. The one of the other things, for those of you who are going to be using Conda environments of any kind, and in general, like I mentioned, for software, please put it in global common software. That's going to be the most performant. So the way for Conda environments, and I don't remember how much we talk about this in the Python talk or in the some of the other talks, but conda environments are often used for Python. They're not just for Python. It's a package manager, and it helps you keep track of all your different. I mostly used it for Python. All your different Python packages, and you can set up an environment that has all the correct packages and the correct versions. Um, Once you have perfected your environment, your conda environment, you're going to want to move it into global common software, and it'll make it much faster and safer to use on our system. So that's something we highly recommend. Anything that was installed with any of these, make, CMake, something like that. In general, please don't generate millions of small files, especially not in one directory. If you're able to, if you're writing code that you're running and you're like, oh, I need to save all these little things, find a way to aggregate it so that the reads and writes are done in bigger chunks. That's going to be much more performant than writing a million small files. So we have something called DVS on our system, which is the data virtualization. What does the S stand for again? System software? I don't remember what S. I remember data and I remember V is virtualization. I don't remember what S stands for. Um, but it's an IO forwarder. It's part of our system as a Cray system, and it has a few quirks. You may or may not run into these. So we have a couple things we like to mention. And again, sorry, this is like a wall of text. I don't expect anyone to read this. So I'm going to just go through the things that are the most important. Conda environments can cause a little bit of an issue with DVS. So the best thing to do would be a container, or as I mentioned, global common software. So if you're going to be using Conda environments, you can work on them and create them and tune them in your home directory, but you should not run them from your home directory because this then can actually cause a bunch of problems. What you want to do is create them, work on them, whatever, and then move them into global common software. Okay. In general, best choice is always Scratch. You may never have to think about this if you're just running in and out of Scratch. Probably is not going to be an issue. And then the other thing is there, as I mentioned, there are times when Scratch is not going to be big enough for your needs, and you're going to need to run out of CFS, Community File System. Um, but there is a special amount of CFS on the compute nodes that we would prefer you to use because uh, it is optimized for use with this DVS system on Perlmutter. So instead of using the global mount, so this means like in your input scripts or whatever, if you're pointing to a location on CFS, instead of having the first uh, sort of file or whatever, this first part of the file path be global, have it point to the DVS RO, which is DVS read only mount of CFS, and that's going to be again more performant. So the rest of it is going to be the exact same. It's going to be, wherever it is regularly on CFS, regardless. But the first thing you want to do is change this out for the read-only mount. And avoid ACLs, which I actually don't remember what those are, but if you know what they are, maybe don't use them. Okay. The next part here is about data sharing. How are we doing on time and how are we doing on questions? Okay, not a ton of questions I'm seeing.
Yeah, and we're pretty good on time as well. It
Okay,
take me long for Python, and then we can do the last Mentimeter stuff.
okay, sounds good. Okay, so let's go through some of these data sharing methods. So inside of NERSC, as mentioned, we have the community file system. So if you're just sharing with people in your project, that's the easiest way to do that, is just have it in the community file system. And PIs have the ability to change permissions using the PI toolbox. So if you are a PI or you need your PI to do something, they can ask us to help them, but it'll be faster for them to use this PI toolbox. Um, oh, is my NERSC depreciated? I
Yeah,
think it is. I
Yes.
think this is in Iris now.
Yeah.
Yeah,
right.
okay. Right. So sorry. So instead of this saying my.ners.gov, this should say iris.ners.gov. So I'll fix that. I forgot to fix that. Um, you could, this is, technically you could do this. I guess if it's a huge amount of data, you could put it on HPSS and that becomes group writable, readable. This may not be the most efficient solution, but it is a solution. If your data is tied to a collaboration account, there are ways for managing shared data across collaboration accounts. So if you're ALS or Daisy or one of these big collaborations, they have collaboration accounts, and there is a way to share data easily among other people on the same collaboration. There is also a way to share data by changing the sort of file permissions, the Unix permissions of your data in Scratch. So we suggest you change it to be read only, and then people can copy it over, and then they can change it to be, then um, they can do what they want with it from there. Or I guess they have to make it read write, and then they can copy it, and then maybe you can change it back to read only or something, just to make sure that people don't accidentally change your version of it. So this is possible to do by changing the Linux permission. So there is your little, chmod, chmod command here if you know how to use that. If you don't, go to the documentation and it will explain some of these things and how to change those permissions if you need to share across, with someone else at NERSC, right? So this is all inside of NERSC. We also have, and this is really nice, and I actually prefer this, is this mechanism called give take. And so the way this works is once you're logged into Perlmutter, you can type give, and then -u is the flag for the username of the person that you want to give the file to. And then you can give them a file or a directory. So you would say, so if you want to give me a file, you'll say give _ u L Gupta, that's my username, and then the name of the file, hello world.py or whatever, or a directory, right? Which you should put the file path to the directory or the file path to the file. And then I actually will get an email saying, oh, Charles has sent you a file. It'll actually say the name of the file and it'll say who sent it because when I go into the system, I log in, I need to take it. And just to confirm that I know what I'm doing, it will ask, well, who sent it to you? So you need to know you're getting it from another person on the system, not just some random person. So I need to know who sent it to me and what did they send me. So it'll be the file name, or I guess maybe the directory. Um, and so there, again, as usual, there's documentation, but this is a really good mechanism for just sending little file, single files, things like that to other NERSC users, especially if you're just like sharing your run script or something like that. This is really, really convenient. Um, Sharing with external collaborators, there are a couple different ways to do this. So there is a public HTML space for your project. So your project within CFS, the community file space, the project, usually is called M. A lot of times they're called M and then a bunch of numbers, but they might have some other names. It's the name of your project. And then you can create a www space where now you can put data that's open to the world, right? So you need to make sure that this is something you're okay with the potentially, I guess, the whole world having access to. So be careful. But there may be situations where you do have public data that you'd like to put out there, and then it is accessible at this URL here. Okay, so that's one way to do it if it's something that's open to the whole world. We also have science gateways. So these are specific web portals that allow you to interface your data, um, and actually more sophisticated things too. You can make really cool web applications. So if you're like a web developer as well on the side or something like that, you could probably make really, really cool websites with your data, because you can mount certain, files to the back side of these science gateways, and you can make databases available to other people. You can make just certain data available. And the way to do that is a service that we call Spin, which Rebecca mentioned briefly. There is a Spin training that's offered probably once a month. And it's fantastic. So if you do feel like you're going to be using or creating any of these science gateways or you want to, or even if you don't know what that is, but you want to find out about it, I highly recommend taking the spin training. It's very good. And then the other thing we recommend is this service that's called Globus. Globus is a really, really secure, sort of well-made uh, method for sharing data across the internet with other people. It's very safe. You can use the web page to send, or you can use the website to set this up and send actually very large amounts of data safely and without, you know, any corruption to yourself, maybe on another system or collaborators somewhere else in the world who don't use NERSC, and so forth. So we have a lot of information on how to do that. And I think at some point there's going to be a slide that goes through instructions, but really I'm going to skip that because it's really just copied out of the documentation. So if you need to do it, you're just going to go to the documentation and use the really good instructions there. Um, Another thing that we provide is these dedicated data transfer nodes. So these are specifically meant for moving data, and they're set up specifically for high bandwidth transfers, data transfers. So they're specifically meant for transferring between a lot of the other major facilities. Well, they're kind of set up for that. You can send things anywhere, but they are, I guess yeah, monitored bandwidth capacity. So this is, sort of set up for doing that kind of thing. They have direct access to the community file system, HPSS archive, and uh, yeah, so for smallish files, smallish is the reason I read that is because it kind of depends. You can basically just use SCP, which is secure copy, and then just specifically ask to use one of the DTNs. So there's let's see, are there only four DTNs? I don't remember. But there's a couple DTNs, and you can specifically ask to use one of those to do your SCP. And this shows how you would move from either to NERSC or from NERSC to whatever other system, whatever data you want to move between systems. Um, okay. Yeah, so Globus, this is more information about Globus. Like I said, we really recommend it, and we have a lot of support for it. I'm not going to go through all of these things, but it does have like this drag and drop feature. We provide a bunch of scripts and commands for this. So this is the documentation. It's got the full how-to instructions. So if you go to our documentation, it literally tells you line by line like how to do Globus transfers. So if you're going to be doing this, please use the instructions that we provide. Um, let's see. Uh, okay, this is yeah, so a couple last things to consider. Performance can probably limited in a lot of different ways, but it might be limited by the other end of wherever you're trying to send data or receive data from. So just keep an eye out that, internal data transfers within the NERSC environment are usually really fast because we have them sort of well optimized for doing that, but we can't optimize to like every external system, so that might be a limiting factor. Um, let's see. Um, if things are slow, sometimes it's really just like just wait a second, try it at a different time, try a different file system. In general, the home directory is not set up well for any kind of intensive I/O. So if you're going to be doing a huge amount of data reading, data writing, any of that, use one of the other systems. And if you're using Scratch and you're still not getting the rates that you would expect, things are taking a long time, then you really do want to reach out to us because we probably can help you understand what's going on. Okay, so this is my last slide. It is just sort of a little infographic of our sort of file system landscape. In general, we have, increasing data rates up here, increasing storage space down here, and then we have our two kind of uh, other systems, the global common software and the home environments. And this is just a couple little rates and space reminders for you. This infographic's available in the Absolute Beginner's Guide. And if there are any questions at this time, I'm happy to answer those. And that is the end of the data talk. Great, yes. So bring large data sets into NERSC from outside Globus. Globus, Globus, Globus. Great. Any other questions, comments?
Any
All right.
questions for Lippy on data? One thing I definitely want to drive home is making sure users know you are responsible for your data. We are not. We do take snapshots and do several backups, but data in like Scratch, we do not back up. And if you, again, as Lippy mentioned, if you do not um, touch it or access it appropriately, after 8 weeks, it gets removed. And we get a lot of tickets from users that panicky about the data. And once it's gone, there's nothing we can do. So it's very important that users take responsibility and know that NERSC policy is NERSC recommends that you back up all of your data off of NERSC systems.
Yeah.
So please make sure that you're aware of that, because there's no point in you doing your simulations and getting all of this data if you do not back it up appropriately, and then it's gone in a couple of months or weeks. So
Awesome. Okay.